Yeah, folks. So welcome back. Sorry, some technical issues with this tablet today, but yeah, now it's back on track. So in our last class, we had some basic discussions on it, right? And yeah, in fact, yeah, just a quick survey, I would say. Some of you have dropped me the email saying that they would prefer to have recorded videos, just like in case of software engineering. So is it the case, or you're fine with coming online and then teaching?
Sir, online teaching is fine
Yeah,
rather than recorded.
yeah. In fact, for 1.5 hours lecture, I feel online teaching is something which will be appropriate. Right, for 1 hour lecture, sharing the videos is fine, but for 1.5 hours lecture, I feel this is something which is appropriate. But anyways, any other views? Any other views? See, you can drop the message also, because I am available with two devices. One for looking for any query which you have. Another is for the for writing and changing slides and other stuff. So any other view? As I said, I can look into what you people are typing, or what if you're raising hand. So I'll be able to get that particular part as well. Okay. Anyways, so it seems coming online, which I also feel the same, is will be fine, because unlike 1 hour lecture, this time we'll be having 1.5 hour lengthy lecture. So this kind of setup will be fine. So in the last class, we were talking about the evaluation method. We had a discussion on CIF as well, and we said that okay, we are not going to follow this one. We had a separate mm, evaluation scheme which we have discussed and finalized, and I'll separately share, because I see the class strength is comparatively on a lower side. But anyways, yeah. So we saw some basic definitions about software architecture, and where we said that this is basically a blueprint of how we are going to build it. We'll be able to see the overall structure of the software. We'll be able to see the components which will be with this application, and how these components will be interacting with each other. And not only the components, sometimes we'll see some external agents as well. And this architecture. Okay, I have a question for you guys. uh, what's the purpose of this architecture? Why we are going ahead for this? Because for this, I need to hire the software architects. I need to hire the architects, and I have to give time also, because they'll also take time in coming up with the software architecture, right? So why we actually need it? We can simply skip it, skip this particular part. We can directly jump for designs, and then we can start developing the applications. Yes or no?
So the architecture will act as a blueprint and then help us develop better when the steps are defined. So we won't have to waste time figuring out what to do next, because we already know a basic structure that we have to follow while developing the project.
Right, very correct, very good, Tanisha. And in fact, I'll take a case from our daily life. Let's say I have a piece of land. Now I want to come up with a house, right? So instead of directly thinking that okay, let's come up with some boundaries, come up with some walls, and then floors and ceilings, uh, I have to plan it well in advance. I need to come up with the structure. I need to come up with the architecture. I need to come up with a blueprint, right? So similarly, in case of software architecture, just to get an idea and just to get a feel, I need to come up with that, because that would be very handy for our design team, for our coding team. Just like in case of coming up with a building architecture and not only building architecture these days, once my building is ready, I'll plan for interior designs. So they'll also give you a blueprint, right, that you will pass on to some interior designers, to carpenters, and to some other people who will be working on it. So that blueprint also comes handy, and that gives, and with the help of that blueprint you get a feel that okay, this is how my house is going to look like in the coming days when it will be ready. And based on that architecture or blueprint, we take a call that okay, this a particular thing, let's say, is not looking good, so let's bring some changes to it. And there, in case of software architecture, we get an idea that okay, this particular component is not serving our purpose, so let's make some changes. Then there we can get a idea that okay, based on this architecture, we, our product may not fall into the actual budget we have proposed for. So for that sake, once again we may bring some changes. It can be technological changes, it can be the changes in case of your let's say some platform changes, and so on and so forth. So that for that sake we need to have this software architecture. Right. So we saw some definitions from, yeah, one very popular book by Bas Clements and Casman, and then we saw uh, that what all things are there in this architecture. Then we looked into the basic definition which we took from this ISO IEC 42010, and then we had a discussion on basically this architecture which is defining the structure, it is defining the behavior, it is focusing on some significant elements as well, it will be balancing the stakeholders need. Because see, I may come across a situation where I'll say that okay, looking at this architecture, uh, I need to bring some changes in the components. Right. So as an end user, I am expecting that okay, this component can be changed, but the developer will say that okay, this is not going to fit into your budget. Provided a blueprint of okay, some issues. Okay, some issues at my end, it seems. Uh, at my end, I feel it is fine because I can see this. This side, I can see it's like it is taking the audio. I hope I'm audible now.
Yes, sir.
Yeah. Okay, fine. I don't know what happened all of a sudden. So, what was the point I was covering when when you people missed my voice? What was the last point which I was covering? Okay. So that means we have left one entire point. So, post behavior, what I was saying, that this architecture balances the stakeholders need as well. That means, right, sometimes I may say that, okay, in a particular project, software project, a particular component needs some change in a particular way. Now, this is, I am saying from the end user's perspective, right? But the developer will say that, okay, based on the kind of budget you have, this thing does not looks feasible. Right. Recently, I'll share you an incident I was sharing. In fact, till the time I got to know that my voice is not available. So I gave a design to my carpenter to come up with a particular shelf, right? And when I gave it, this carpenter accepted and said okay. And then when we started, then carpenter came back to me saying that whatever you have proposed looks good, but it will not be feasible because it will not be able to handle the load. It will not be able to handle the load. So we brought some immediate changes and we brought some changes in the design, and then the things started. So it's like, from my end, because that design was looking fine, that architecture was looking fine, I passed on to the carpenter. But from the carpenter's experience, he said that okay, it will not be able to handle the load, so let's bring some changes. So we reached to a point where we both agreed, and I also understood that yes, whatever inputs he has given is also correct, right? So that, and now this has happened at a very early stage. If he would have simply followed the designs which I had passed on, so in that case, once the product is ready, I might have faced difficulty in using it, and then I would have blamed the carpenter that what kind of thing you have come up with, and it's not sturdy material at all. But here, since we had the blueprint, so at the very beginning we took a call that okay, let's bring some changes to it, so that we reach to a point where everything is fine. Now, coming back to this, we also talked about the environment, because of which this gets influenced, and then the scope and other stuff. And I guess we have to start from this particular part. Yeah. See, these some of these set of slides, you might feel that you have uh, already covered in case of your software engineering course. But this is just a single set of slide where you'll find some amount of overlap, just because to give you an idea about or just to brush up some of the things which you have already studied. Now, in this particular thing, you'll see that what is happening, that all the stakeholders are sitting, and the requirements are passed on. See, everywhere you'll find two-way arrows. The reason being because it can be we can come across a situation where the client passes on some requirements to the architect. Architect tells something and provides some feedbacks and says that it would be good if you can refine some requirements. So once again, the clients use and the end users get the feedback from the architect. Once again, the requirements are passed on, and once this architect come up with the architectural design, right? This has passed on this, and this architecture based on this design has passed on some solution to the developer as well, because this architectural design will be at the end uh, will be assessed by the developer. So once again, you'll see a two-way uh, arrow here as well, because sometimes developers may also provide some feedback that can be based on that how my external agent is available these days, or how my external agent behaves these days, and then from this end also I may get some extra valuable points for the architect. Now this developer will be assessing and will start this particular part, and the clients who provided the inputs got this architectural design. With the help of this, I'll be able to, or all the stakeholders rather, will be able to get an idea of the appearance and the behavior of this to be developed project. And this is not only in case of the architectural building, it is also, in case of your software products as well. Right. So we have the architect who is taking some requirements and providing some inputs parallelly, providing some solutions in the terms of the architectural design, and this architectural design is helping the end users or the all the stakeholders in visualizing this to be built product, and that is also helping obviously to the developer as well, that how the developer has to proceed in coming up with this actual product. So here you will see we're not going into the technical details of the implementation of the product, right? We had a point previously also where we said that okay, we are not going into the implementation details or the technical details of this particular part. Now the next thing is that previously what we had was the pre-architectural life cycle. This the life cycle is, you can see a part of your SDLC. What was SDLC?
Software development life cycle.
Right, very correct, very correct. Yeah, I thought some of or many of you might have by this time missed what basically the SDLC was, because uh, in our software engineering we are dealing with this topic on daily basis. So what we have is like we have the stakeholders who have provided the requirements, right? And then we see the refinements of the requirements, and we have some quality aspects which we have incorporated, and we came to an agreement. Then we further initiate the development. Now the thing which is missing is your architecture, right? The thing which we are missing is the architecture, and in this case I'll not, in fact, by looking at this cycle, you might say that okay, we are not getting the actual feel of the product. So let's add the architecture in a very simple way, right? And how to add it? Rest everything remains the same. In this development phase, right? In this development phase, we said that we'll have the architecture, we'll have the detailed design, and we'll have the implementation part as well, right? So looking at this, I can say that still we are very late in introducing the software architecture, right? We are very late in introducing the software architecture. Now what to do then? So what we can do is, because see, quality we've already talked about separately. We came into an agreement, and then we started development where we had the architecture. And in this case, let's say during the development phase, I observed that the architecture is giving me a sign that few things are not acceptable, right? So in that case, by this time my stakeholders are also not here. I can I cannot further refine the requirements. So what I can do is I am adding the architecture in the life cycle. So we have like stakeholders, we have the requirements, we have the quality, right? Quality aspects, and then we have introduced the architecture. And this architecture can further be refined based on what discussions we had in this particular slide, right? Because now, with the help of the architecture, I am able to visualize how my software is going to look like. I am able to provide some input, right? See, all these stakeholders will be like the customer, the end user. Sometimes your customer will be your end user only, right? And the developer, right? Here you can also add client, right, for the developer. So any term is same in this case. So all these stakeholders are there, and looking at the architecture, they'll say that okay, this looks fine, or it needs some changes. Then there and then only we can talk about if any extra expenses are there or not. Right. So in that case, all the things will be discussed here, and then we will move forward to the yeah, probably some issue with the internet connectivity was there. Yeah, because I lost the connection from both the devices. Some internet connectivity, surprisingly, happening today. Uh, yeah, so uh, where I left, I mean, just because of this internet connectivity issue, what was the point we were discussing?
So we were discussing what was stakeholders. Like we have discussed that stakeholder contains these.
Okay. Let me once again explain it. I don't know how come some internet connectivity issue was there. So what we are saying that in this case we have like stakeholders. Stakeholders can be your end users, can be your customers, and developers on one side. Sometimes you'll identify that your end users and customers are the same, right? Because see, it can be like I have a company, right, who is developing a product for the ICICI Bank, who are having some customers like us, right? And sometimes it can be like for a product is developed for their internal purpose, right? So it would be like ICICI is the only one. Now, and sometimes you can address the entire bunch as client. For the developer, they are client. Right. So it remains the same. So some terms interchangeably can be used. So here what we'll say that we got the requirements. We have talked about the quality aspects. Quality here once again, your all those non-functional attributes: security, correctness, availability, portability, accessibilities. And based on these two things, we came up with some architecture. And since all the stakeholders are involved, if required, some refinement will take place. And once it's done, the agreement is signed. So it gets freezed, architecture gets freed. You then sign the terms and conditions. That means the agreement takes place, and then the development takes place, and further, deployment.
Freeze.
Yeah, Rahul.
Oh, sorry, sorry, sir.
No issues, no issue. Yeah. So yeah, so then the development starts. Any doubts up till now? Any doubts? Okay, okay, okay. Yeah, so now let's talk about we have already discussed, but let's formally talk about it. So this helps us in understanding the system, right? This helps us in understanding the system, and if I'm able to understand the system, then definitely I'll be able to handle the complexity as well, right? I'll be able, if there is any, if there is any, I'll be able to understand that particular part as well. So this helps us in organizing the development process, because once I am able to get a blueprint, right? So in that case, I'll be able to plan it accordingly. That okay, during the initial stage, what we can do, and during the mid phase, what we can do. And because see, when we talk about the architecture of a software, we talk about the plan, right? A plan which describes your set of aspects and decisions that are important to a software. That means we are talking about considering all kinds of requirements and then organizing the system as well. And just because of all these things, this software becomes very important, because this becomes software architecture becomes important. The reason being that it becomes a basis of communication, right? Because we'll be able to sort out the entire software plan with the help of the software architecture, and for the understanding, for the negotiation, for the communication between all the stakeholders, this is software architecture becomes the basis of communication. And obviously it organizes the development process as well, and with the help of it I can take some early design decisions. That means like the first decisions are made at this stage, that how my software is going to look like, how it is going to work. And then those early decisions have a huge importance on the rest of the project, and this becomes very difficult to change. And because if suppose at a very early stage, if I'm able to bring some changes, then it's okay. At a later stage, it becomes very tough, right? So we get to know the constraints on the implementation, that okay, what things are easily doable, what are the constraints, and this dictates the organizational structure as well. Because with the help of this, I'll be able to get to know, let's say, the number of modules, and let's say the kind of product which we have, or the kind of module. Based on that, I'll take a call that okay, for this particular project, what kind of team I need, how many testers I need, how many developers I need, how many front end developers I need, how many back end developers I need, how many people I need for UI UX, right? So all these things will be helping us in taking some early design decisions. So this inhibits or enables the quality attributes as well. So in every sense of software architecture, we are planning to come up with a correct software. For that, directly or indirectly, I'm addressing your quality attributes only. Right. So whenever we are talking about a software architecture, I'm talking about quality aspects. Now this point, software architecture is transferable and reusable model. Now this is something which is very crucial, because this also enables your code reusability as well. See, if I have a software architecture for, let's say, a university MIS system, so that will help me for, let's say, for if suppose I have to come up with the MIS application for, let's say, 10 universities. So out of these 10 universities, at least 6 will have a similar kind of architecture. Some will have some major changes, or else we can customize those things, because every university will have attendance management system, every university will have grading, marking, grading, transcript generation system. So those things will be common. So what we can do is we can transfer it, we can reuse this sort of software architecture we have, which I have built for one application. For rest other 5, I can simply come up with, along with some minor modifications or customizations. Right. So it becomes a very easy, and it obviously saves a lot amount of time. And now once I have identified the reusable component of a particular software architecture, then I'll be comfortable in reusing a particular piece of code as well. Right, I have identified the architecture, the portion which is transferable, then I'll be able to reuse the codes as well. So obviously that is going to save a lot amount of time, and that is obviously going to save a lot amount of money as well. Getting this point? See, in case of transferability of the model, basically your software architecture will be defining the model of the software, and along with the model, how it will function. Right, all these things we will be able to get from software architecture, and this makes it possible to reuse this model for other softwares as well. And if I'm able to identify the model or the module even, so I know my code can be reused, and then I can also reuse some of the requirements as well, right? And all these experience we get while we are transferring the architecture. So we get to know how much we can reuse and what can be the consequences of some early decisions, because we already we already used a particular portion of architecture or the entire architecture in our previous products as well. So for to be built application, we'll be much more careful, and we'll have a better picture as well. So in some sense, we can say that the architecture will define the problems you might encounter when it comes to implementation. Right. Getting my point or not? Yes or no? Okay. So in some sense, we can say that the architecture will define the problems we might encounter, and we'll be able to get the organizational structure, and that will help us in taking some very early clear cut decisions, and we'll be able to manage the things, and we'll be able to sort out the problems associated. Now next is like when the software architecture started, right? So in case of your first, in the year 1969, we had this NATO software engineering conference, where this thing was introduced, that I think we have something in addition to software engineering. This is a subject of software architecture, and architecture is different from engineering. Engineering will be the next step, right? Engineering will be the next step. Now, other points of view are like, obviously, your architecture is a high level design. This architecture is nothing but the overall structure of my system. This architecture is the structure which includes the principles and guidelines governing their design and the evaluation over time. And yes, obviously, when we are talking about all these high level designs, overall structures, so this is nothing but the components and the connectors which are connecting those components. So these are some other points of view. Now, the point is the software architecture and the quality. But before that, let's talk about what can be a very good architecture. Any idea? Any idea about a good architecture? Any idea about a good architecture? See, in software engineering, there are few things which can be reused, right? So when we talk about good architecture, first of all, it's like a very difficult thing to identify what can be a good architecture, because there is always a scope of improvement. Right. So I don't have, a real correct answer to this question, right? But in some sense, we can say that a good software architecture will be producing a cheaper product, cheaper in a sense economic, right? Not about quality. Quality will be obviously on a higher side, plus quality and price goes hand in hand. Plus, it will be easier to develop and it will be easier to maintain. So, your software architecture, like, you should be very strong and should be very easy to maintain. It should be like flexible, it should be extensible, it should be usable, it should be reusable as well, and it should adapt the requirements, and it can uh, be scalable as well. So all those points which you have studied about software quality also applies to software architecture as well, right? And then we should have like user friendliness should be there, and then it should be flexible, it should have some high performance and other stuff. Now let's formally talk about your software architecture and quality. Yeah, very detailed one as well, so the notion of quality is central in software architecting. So a software architecture is devised to gain insight in the qualities of a system at the earliest possible stage, and some qualities are observable via execution, and these can be your performance, your security, your availability, your functionality, and your usability. And some are not observable via execution as well. These can be your modifiability, your portability, your reusability, your integrity, your testability, right? So these are something which are not observed. Now, these are some of the examples of the architectures, right? We have like software architecture, we have solution architecture, we have logical architecture, we have technology architecture, we have information architecture, we have platform architecture, we have technical architecture, then we have system architecture, we have code architecture, we have deployment architecture, we have enterprise architecture, then we have like application architecture, and then we have like conceptual architecture. Then you'll have like layered pattern architecture. You'll have client server architecture, and then you can have event driven architecture. You can have microkernel pattern. You can have microservices patterns, right? So to start with, what we have is we have enterprise level softwares. Any idea about enterprise level softwares? What are enterprise level softwares? Big companies, yes, yes. So basically, when we talk about enterprise, Rahul has given a very correct answer, very correct in a simple way. So enterprise applications are for the purpose of the entire organization or entire enterprise. So, these softwares are not meant for individual users, right? And this can be for, let's say, for businesses, for schools, for interest-based user groups, and it can be for, let's say, a government organization, and it can be for let's say for our university. It can be for our entire university, right? So that would be a huge software that would serve all kind of purpose. That means from, let's say, attendance management to payroll management to inventory management to store management to hostel management to mess management. So all these things will be added, and then we'll come up with the enterprise level software. That means a single software serving all purposes. So this is a solution architecture. We'll talk about some set of architectures, because this list is huge, but still we'll talk about some important ones along with some additional ones, just like layered pattern architectures and other stuff. So in this, what we have is we have the requirements. We feed to the solution architecture, and these can be managed and can be engineered. A very simple one, a very simple one, where what we have is we have supplied the requirements to the solution architecture, and what this solution architecture is providing us are the requirements which can be managed and can be engineered, right? So we, in some sense, we are getting some solution out of this architecture, and this can be any way. It can be any way. Solution architecture uh, is like, in some sense, it is also, in short form, it is as SA. So this is like a description of a discrete and focused business operation, or it can be activity. But since we are addressing the enterprise level software, so it will be for the entire business organization. So your solution architecture is like one of the key component by which your enterprise architecture delivers values to the organization. So it provides some artifacts such which can be, let's say, your solution, right? Your vision, looking at your requirements, and then it comes up with the optimal solution, right? And then we build and we implement those plans and roadmaps. So this is how your software architecture works. Now, yeah, this next is your 4+1 view architecture, and I this needs a good amount of discussion. So this I'll prefer to have in the next class, where we'll only talk about 4 plus 1 view plus other architectures such as layered patterns and other, because here I need to explain with the help of some examples. I need to take some case study, so that would be a lengthy topic and I'll stop here. Let's take some doubts, and whatever doubts you have, let's have those things, and then we'll talk about 4 plus 1 view. Your 4 plus 1 view is very interesting topic. I would request you to inform your friends as well, so that you don't have to go back and turn the pages in order to understand this 4 plus 1 view architecture. That 4 plus 1 view architecture paper is very lengthy one, right? So that takes a good amount of time in reading. I'll try to explain in a very simpler and easier way, and obviously it's an important topic, and that would help you in not only in your midsem, endsems, or evaluation, but will also help you in the outside world as well. So, anyways, let's take some doubts now.
So, like in modern SDLC models like Agile and DevOps model, do
Yeah.
we make these architectures because these models require rapid delivery of applications?
Yes. Now, in case of rapid application development model or agile, what we do is that we stick to a faster development, right? So even if we are coming up with a software architecture, we'll first of all we'll try to avoid it. Even if we'll try to introduce it, then it would be a very rough layout, because here time is something which is a major constraint. But in case of large projects, architecture is something which is must.
Yes, sir.
Yeah. Okay, solution architecture is nothing but what we are trying to get is, in case of enterprise level software where the size of the software will be huge. So I'll come up with a solution architecture in order to get some solution and some vision based on the requirements. Right. So it's like, let's say I have a university MIS, right? So my solution architecture will identify that, okay, this needs to have a payroll management component. This needs to have attendance management. This needs to have the course registration. This needs to have your course registration, let's say hostel management, and so on and so forth. So this will give me a vision. This will give me a vision. This will give me a solution. Right. That's how we get an idea that, okay, that's how we are going to proceed now. Clear, Abhinav? Okay. Any other doubts? Any other doubt? No. So probably we'll take a pause here, and in our next class we'll take our discussion forward. See you then. See you.